Hello everyone and welcome to GeeksforGeeks. Today we are going to discuss a very important data structure, that is stack. So what is stack? Stack is basically a linear data structure and it performs the operations in a particular order. So the order is LIFO or FILO. So what do we mean by this is that the operations like insert or delete, so they will be performed in LIFO fashion. So by LIFO we mean last in first out. So whichever element was inserted the last, that element will be popped out as the first element. So whenever we do a pop operation, the last element that was inserted inside a stack will be popped out. So in stack, we basically have three types of operations. The one is push, the second one is pop, and the third one is peek. So push is basically inserting an item in the stack. So it adds an item in the stack. Also, if the stack is full, then it is said to be an overflow condition. And we'll see in the implementation that how do we check the overflow condition. Now coming to the pop operation, pop removes an element from the stack. The elements are popped in the reverse order in which they are pushed. So just now we discussed that it's the last in first out. So the elements will be popped in reverse order in which they were pushed onto the stack. Now, if the stack is empty, then it is said to be an underflow condition, which means that the stack is already empty. You cannot pop out another element out of it. And we'll see again in the implementation that how do we check that it's an underflow condition. Then the third operation is the peek, which is basically getting to know the topmost element. So this is the element which will be pushed or popped if we do a push or pop operation. So how do we understand a stack practically? So we have a very classic example of understanding a stack. So a simple example of plates stacked over one another in a canteen. So the plate which is at the top is the first one to be removed, but that plate will be the last one which was put onto the stack. The plate which has been placed at the bottommost position remains in the stack for the longest time. So that again holds true. So it's last in first out or first in last out. Then so it can be simply seen as LIFO or FILO order. Yeah. Now coming to the implementation part of it. So we basically have two ways of implementing the stack. The first one is using array and the second one is using linked list. And in this video we are going to see both of the ways to implement the stack. So first of all, let's start with using arrays. So we have the normal header files declared here. Then we create a structure where we have the array that will be the actual place wherein the elements will be stored of the stack. Then we have unsigned capacity. This will be the capacity of the stack because we are using arrays, so we need to define the capacity upfront. We cannot change the capacity dynamically. And this is the int top, so this will be storing the index of the topmost variable, topmost element basically. So if you have just one element, the index will be 0. If you have two elements, the index will be 1, and so on. Now here we have the function to create a stack. So it takes as an argument the capacity, and then it allocates the memory to the structure stack using the malloc, and then it assigns these three variables, these three basically elements of it. So the capacity, the argument capacity is added to the capacity of the stack. Then the top is initialized as -1 because currently we do not have any elements in the stack. And then the array. So the array is actually assigned the memory. It's actually allocated the memory of the size capacity. So we do the capacity, we multiply the capacity of the stack into the size of integer. Here we are assuming that the stack will have integer elements. If we would have some other kind of data structure here, maybe maybe characters, maybe some other structure, then we can have a different argument here. And then we just return the stack. So this is kind of initializing the stack here. So this function just initializes the stack. Okay, so now we have two utility functions here, which we will be using when we will be implementing the push and pop operations. So the first function is full. It checks that if the stack is already full. So we pass the stack pointer uh, and then we just check that if the top of stack is equal to the capacity of stack -1. If that is the case, in that case the stack is already full, then it will return true, otherwise it will return false. Similarly, we have a function is empty. So is empty again takes as an argument the pointer stack, and then it checks that if the top of the stack is equal to -1. If that is the case, it returns true. If that is not the case, it returns false. Okay, so coming to the most important functions, that is the push and the pop. So in this push function, we have the pointer to the stack, and then we have the actual item which is to be pushed onto the stack. Now we first of all check that if it is full. So if the stack is full, we cannot add more elements, and it will be a condition of overflow. So we just check that if the stack is full, then we just simply return. If the stack is not full, then in that case, we firstly increment the the value of top in the stack. So we do a plus plus top of stack, and then at that index, we basically put the item. So here we are actually putting the item at the incremented top of the stack. And then we finally just print that we have pushed the item onto the stack. Now let's look at the pop function here. So in the pop function, we do not need an item like here because we just need to pop out an item. So we just have the pointer to the stack. Here we'll have the check of is empty. So if the stack is already empty, then we cannot pop out elements out of it. So we just check, and if it is empty, then we return the int main. Otherwise, if the stack is not empty, then what we do is we return the element which is at the current top. So this element will be returned, and then we basically decrement the value of the top. So because we have a the top of stack minus minus here, so it means that the after basically getting the value of this of the top of the value at the top, then it will decrement the top here, and then it returns the value. So the top of the stack is also decreased by 1, and we also get to return the value which was there at the top, so the popped value. Now we have the function peak. So peak just gets the value at the top. So again, it needs to check if the stack is empty. If stack is empty, then it just returns int min. Otherwise, it just returns the value at the index top of the stack. So here we have a driver function to just test out all the things. So here we are creating the stack here. So we initialize the stack with the capacity as 100. Then we push out. Then we basically push 3 elements, 10, 20, and 30. So 10 is pushed to the stack, 20 is pushed to the stack, and 30 is pushed to the stack. Then we do a pop operation, and then we'll do a peak operation. So because 30 was inserted last, so 30 will be the element which will be popped here. So we get 30 popped from the stack. Then we peak. So peak again gets you the element which is at the top right now. So that will be 20. So that was the implementation using arrays. So both the implementation, the linked list implementation and the array implementation, will have their pros and cons. So let's see the pros and cons of the array implementation. So the pros are that it is easy to implement. Memory is saved as pointers are not involved. In the linked list implementation, you'll have the pointers pointing to the next node. So that will be an added memory that will be used. Now, the cons is that it is not dynamic. It doesn't grow or shrink depending on the needs of the needs at the runtime. So even if you just need to use 10 elements in the stack, the space of 10. But if you initialize it with 100, then you'll be actually blocking the memory of 100 elements. In the same way, if you have the capacity, the capacity of the stack is initialized as 100, and now you need to store 110 elements, then you cannot do it using the R implementation because it is not dynamic. You have to tell it upfront that what's the capacity. So to overcome these cons, we'll now see the linked list implementation. So in the linked list implementation, we have a structured stack node wherein you have the data part, and then you have the pointer pointing to the next node. So here each node will contain the data and the pointer to the next node. So this is the structure for the linked list implementation basically. Now again, to create a new node, we have this function new node, which takes as an argument the data part. Then what it does is it creates a new node, basically the stack node, and it also allocates the memory to it. Then it fills out the value of the data part and the next part. So the data part becomes the data part which came as an argument basically, and the next is initialized as null because we do not know where it will be placed, or we do not basically have a value for the next pointer. And then we return the stack node. Now we see the function is empty. So is empty gets the pointer to the root node. Now if root exists, then it is not empty. If it doesn't exist, it is empty. So what do we mean by this? So what will happen is that initially the value of the root will be null because it doesn't have any elements in it. Once the elements are added, it will have some value because it will be pointing to the first node of the linked list. But again, if we pop out that first element, then again the value of the root becomes null. So that's why we just check if root exists, then the stack has elements, otherwise it doesn't. Okay, so then we have the push and pop operations. Note that we did not discuss the is full function because in linked list implementation of the stacks, you'll never be in a situation where the linked list is full because it is dynamic. Okay, coming back to the push operation. So you have a double pointer to the root because we'll need to modify the root here, and then we have the data part. So to push the element, which is the data, we create a new node by passing in the data to the function which we discussed. Then it returns the node to us. Then we actually update the value of the next pointer of the stack node to the root. So we are actually placing it to the as the first element of the linked list. So that's why we are actually putting the next pointer of the stack node to be the root. So we give the value of the root to the next pointer. Then we actually update the root. So now the root should point to the stack node. Once this is done, the element is inserted, the pointers are updated. We just print that the element has been pushed. Okay, so now similarly, let's look at the pop operation. So in the pop operation, we'll have the check for is empty. So if the linked list is empty, then we cannot pop out more elements. Same as the case in the array implementation. Otherwise, what we do is we keep a pointer to the root node, because which is the first node, because we'll have to free the memory in the end. Then we update the pointers, so the root will now point to the next of the root. So we update the pointers basically. Uh, yeah, so we update the pointers here, and then we get the popped value. So from the temp, we get the popped value, and this popped value will basically return in the end. And also we'll use the temp value which we stored here, which is the popped element from the linked list. We actually free the memory. So once we allocate the memory using the new node, and then we free the memory using the free here when we pop out the element. Okay, now let's see the peek operation. So peek again checks the if the linked list is empty. So if linked list is empty, then it returns the int min. Otherwise, it just returns the data part of the root node. So the data part of the first node. Okay, so let's look at the driver function, how that will be looking. So we initialize the root node as null. So that's why the isEmpty function is working, because the root node will be initialized as null. Then we push three elements like before, 10, 20, and 30. So all the three elements are pushed onto the stack. Then we pop out an element. So 30 is popped because that is the topmost element, and that is the last element which was inserted inside the linked list. And then we do a peek. So it should return now, because 30 is now already popped. So it should return 20, and that's what it returns. So now let's see the pros and cons of linked list implementation. So the pros is that it is dynamic. It can grow and shrink according to the needs at the runtime. We do not need to worry about it. But again, the con is that it needs extra memory due to involvement of pointers. So that will always be there with the linked list implementation, because you have to keep the pointer pointing to the next node. Now, just to get the applications of the stack. So there are numerous applications of the stack in real life. So when you have a problem of balancing the symbols, or infix to postfix or prefix conversion, when we do redo or undo features at many places like editors, Photoshop, Microsoft Word, at that places the software internally maintains a stack. Forward backward feature in web browser, again that it uses the power of stack data structure. Then many algorithms like Tower of Hanoi, tree traversals, stock span problem, histogram problem. So all these problems uses the stacks. Other problems could be backtracking, night tour problem, rat in a maze, and queen problem, and Sudoku solver. So all of these problems actually heavily use the stack, and the solution is based on the implementation of the stack itself. Okay, so that was all for this video. Thank you very much.